All right, let's dive right into this explainer, where we're going to bridge the gap between basic Python scripts and fully functional, cross-platform graphical applications. If you've ever built a text-based Python program and caught yourself wondering, how do I actually turn this into an app I can tap on my phone? Well, you are in exactly the right place. We're going to unpack exactly how that's done.
Here's our roadmap for today. First, we'll meet the Kivy framework. Then we'll set up your environment, learn about designing with the .kv language, build out a user interface, and finally, package the whole thing up for Android. Let's get to it.
Starting off with Section 1, meet the Kivy framework and getting into Python GUI development. So what actually is Kivy? Well, if you want to build a modern app using Python, Kivy is an absolute powerhouse of a framework that makes GUI development incredibly accessible. It literally breaks you out of command line jail. Instead of staring at a terminal, Kivy gives you all the pre-built tools you need to construct really rich visual user interfaces and seamless multi-touch applications. And it handles all that complex rendering completely behind the scenes.
And here is the absolute game changer, Kivy's biggest selling point. You write your code once and you can run it practically anywhere, including right on your mobile phone. It's engineered to operate exactly the same whether you boot it up on Windows, Mac OS, Linux, iOS, or Android. And it does this by supplying its own unified set of widgets, rather than relying on the native system's visuals. That guarantees your app's going to look and behave consistently no matter where it's running.
Moving right along to Section 2, setting up your environment and getting ready to code.
Setting things up is a pretty straightforward pipeline. But a massive best practice rule here: absolutely isolate your project using a virtual environment before you run your pip install commands. Now, if you're on a Windows machine, Kivy requires a compiler, so you're going to need to grab the free Visual Studio build tools first. Once that's all sorted out, just fire up your virtual environment and simply execute pip install Kivy right in your terminal.
Now, to make your workflow incredibly smooth, you'll definitely want to install the Kivy KV helper extension in VS Code. It automates a ton of the heavy lifting for you. It gives you syntax highlighting to make your code super readable, it auto-imports missing widgets directly into your Python file, and it gives you really intelligent autocomplete for Kivy attributes. It even gives you a hotkey, F5, for a super fast preview, which means you can instantly see the UI you're building without having to manually restart your script every single time.
Okay, Section 3, designing with .kv, and how we separate our UI from our logic.
Think of the .kv language exactly like HTML and CSS in web development. It strictly handles what the user sees. It's a declarative design language built specifically by Kivy, because let's be honest, you really don't want to clutter your main Python file with hundreds of lines of code just to specify button colors and layout padding. Instead, you define all of your styling and element placement cleanly in a dedicated .kv file.
Separating these concerns is completely crucial because it keeps your Python file squeaky clean and focused purely on the application's intelligence. On one side, your Python script is the brain. It runs the math, handles the logic, triggers events when a user taps the screen, and inherits the core Kivy classes. On the other side, your .kv file is the canvas. It manages the visual hierarchy, the styling, and exactly how those widgets are physically laid out on the display.
Now, Kivy will actually automatically link your design to your code, which saves you a lot of manual configuration, but only if you follow its strict naming rules. First, the file name must be entirely lowercase. Second, it has to match the name of your main Python class. And third, and listen up because this trips a lot of people up, if your main class ends with the word app, you have to drop that word from the file name. So if your Python class is named calculator app, your visual file simply has to be named calculator.kv. Simple as that.
Let's put this into practice. Section 4, building the UI and constructing our layout.
When you're hacking away inside your .kv file, you've got to treat it with the exact same respect you give Python. Indentation and capitalization literally determine the entire hierarchy of your widgets. A single misplaced tab can completely break your layout, because Kivy relies on that indentation to understand which widgets belong inside which layouts. It's a strict, but honestly, very clean visual tree. Let's say we're building a simple calculator. For our visual scaffolding, a grid layout with 2 columns works perfectly to align our text prompts right next to the user input fields. By defining a grid layout and setting the calls property to 2, Kivy automatically manages the grid for you. The first widget you add sits on the left, the next sits on the right, and the third automatically drops down to form a brand new row on the left. It is incredibly efficient for building forms. To wire all this together, it's basically a 3-step dance. We stack our input widgets inside that layout,
add a clickable button to actually run the math, and finally return this entire layout through the build method in our main Python class. You instantiate the layout, populate it with labels and text inputs for the numbers, bind a button to a function that processes that input, and then just tell the app to render the whole shebang.
And now for the grand finale. Section 5. Packaging for Android and deploying your app natively.
You've actually got a few different options for deployment here. As you can see, Buildozer is by far the most beginner-friendly route because it completely automates the Android SDK and NDK installations for you. Now, you could use Python for Android directly if you really need deep manual control over the toolchain. Or the Kivy Launcher app lets you run simple scripts directly off your phone's SD card without compiling anything at all. But for creating a standalone distributable app, Buildozer is for sure the clear winner.
If you're on a Linux or macOS terminal, it really just takes 3 commands. First up, you run buildozer init to generate a configuration file. Then, you open up that buildozer.spec file to name your app and tweak its parameters. Finally, you plug your phone in via USB and run buildozer android debug deploy run. That single command compiles the code, builds the Android package, sends it right to your device, and launches it automatically. It's practically magic.
So, you've got the tools. You know the workflow. We've successfully taken Python out of the terminal and put it directly into the palm of your hand. You understand how to design and package these cross-platform graphical apps using Kivy, which means the only limit now is your imagination. The real question is, what are you going to build next? Thanks so much for joining me on this explainer, and happy coding!